This is what we have discussed in the last class. You have started the syllabus. Okay, that is from module 1. Okay. So what we have discussed? So we have started with the definition of the title of the subject. Okay, then we have started. Then we have discussed about the forces, types of forces, stress and types of stresses. Okay. So can anyone tell me what you mean by mechanics? Those who had attended the last class. So can anyone tell me what you mean by mechanics? Yes. Mechanics, the meaning of mechanics is nothing but study of forces and motion. Okay, that we call it as a mechanics. And what is study of forces and motion we have discussed in detail in the last class. Okay. And what do you mean by material? This subject is having two words, mechanics and mechanics of materials. Then what is material? Yes, anything which is made up of or made from a matter. Okay, and matter means what? Anything which occupies space and has mass. Okay, and usually matters are made up of atoms and molecules. Okay. So anything which is made from matter we call as a material. And now what do you mean by this meaning of the title or definition of the title? Mechanics of materials. Mechanics means study of forces and motion, and material means which is made up of matter. Anything you can take, you take this chalk, this is also a material because it is made up of some kind of matter. Okay, if you take any desk is also one type of material. Okay, duster is one type of material. Paper is also a material. Okay, so now tell me the definition or the meaning of this mechanics of materials. You have discussed, no? You have discussed 10 to 15 minutes for that. Okay. Yes, the study of behavior of the material under the action of forces and motion. Okay. So here mechanics means study of force and motion. Okay. Now mechanics of material is nothing but the behavior of the material. Okay. The study of behavior of the material under the action of forces and motion. So what is happening to the material when you apply the force on it? Okay, whether the material is getting deformation or not. Okay, deformation means what? Change in shape. So whenever the body gets change in shape, we call it as a deformation. Okay, so when you apply the force on a body, what is happening? When you apply the force on the material, what is happening to that material? Whether that material is getting deformation or not, or whether the body is moving from its position or not. Okay, whether the body is it is at the same position even if you are applying the forces. This is what the study of forces on the behavior of the material under the action of forces. Similarly, behavior of the material under the action of motion. So when you apply the motion on the material, what is happening to the material? Okay, suppose if I apply the motion to this chalk, so whether this chalk is moving or not. Okay, or whether the chalk and at what speed this chalk is moving. Okay, this is what the study of behavior of the material under the action of motion. Okay, so here in this definition we are combining these two, forces and motion. The study of behavior of the material under the action of forces and motion. So what is happening to the material due to the application of forces and motion? Okay, so that we call it as the mechanics of materials. Okay, and also we have discussed about the force. What is force? So there are many definitions. Are there? You get different definitions from different books. Okay, in general, okay, in simple words, we can say that it is an external force. Sorry, it is an external agent which is used to push or pull the body. Okay, if you want to push. Okay, so we are applying some external agent. That external agent is called as a force. Similarly, when you want to pull the body, okay, towards you. So you are applying some kind of external agent. So that external agent is called as a force. Okay, and here forces are classified into many types, but from the point of your syllabus, we have discussed only three kind of forces. Okay, which are those forces? Tensile, compressive, shear force. Okay, so tensile force means what? There are many types of forces are there. Okay, but from the point of your syllabus, three forces are important. Okay, tensile force, compressive force, and shear force. So what do you mean by tensile force? So here, if you take any material, or if you take any body, or if you take any object, okay, if the forces are acting away from the body, means if you are applying the forces away from the body. This is body or this is material. That force I say apply करें this force is going away from the body. Am I right or wrong? So when the forces are acting away from the body, so that type of force we call as a tensile forces. Are you getting my point? So if you take this as an object, or this as a body or any material, okay, here you can see that here it is body. So here I am applying the force like this. Means this force is going away from the body. So this kind of force we call as a tensile force. Okay, next, what do you mean by compressive force? Opposite of that tensile. If the forces are acting towards the body, suppose this is the body. If I apply force in this direction towards the body, okay, that force we call as a compressive force. Compressive force. Compress करेगा. So when you apply the force towards the body gets compressed. Am I right or not? If you take the rubber, okay, you apply the force towards the body, so the rubber gets compressed. Am I right or not? So that kind of forces which are acting towards the body, such type of forces we call as a compressive force. Okay, and next one is what? Shear force. So here, when the forces are acting parallel to the surface or tangential, parallel. The meaning of the tangential and parallel both are same. If the forces are acting tangential or parallel to the surface, this is the surface of the material. Am I right or this is the body of this is the surface of the body. So here you can see that the forces are acting parallel to the surface. Okay. So this type of force we call as a shear force. Are you getting? Even if you apply the force like this, so this is also shear force, because this is the what surface of the body, and here the force is acting parallel to the surface. Okay, this force also we denote as a shear force. Here you can take this like this also, no problem. Here you can see that the forces are acting parallel to the surface. Are you getting or not? Okay, suppose I will apply the force. So that is for that type of force we call as a shear force. Are you getting? Three forces: tensile, compressive, shear force. We have discussed in detail in the last class. Okay. And what is the unit of force? Newton. In short, we write it as a capital N. Okay. And important topic we have discussed in the last class, that is stress. So this is the actual concept we need to understand. Okay, so to understand this concept, we have discussed all these concepts. Okay, what do you mean by stress? So please go through the previous video, those who are not attending the last class. Okay, because these concepts are very basic concepts, you must understand. अभी जो लास्ट क्लास में मैं जितना डिटेल में बोला नहीं उतना बोल नहीं सकता, because again it will take more time. We cannot go further. We cannot. It is very difficult to cover this subject. अगर रोज ऐसे में पढ़ाते क्या कल 2-3 जने फिर नहीं आए, फिर भी पहले से स्टार्ट करते ऐसे क्या हम लोग वहाँ आगे बढ़ते हैं. ओके सो अभी बहुत सारे लोग आज ज़्यादा हैं तो मैं जस्ट आई एम रिकॉर्डिंग द प्रीवियस कॉन्सेप्ट ओके यू प्लीज गो थ्रू द प्रीवियस वीडियो दोज आर नॉट अटेंडेड इन क्लास अगर आपको इंटरेस्ट है तो आप भी देख सकते हो okay and you must be what while coming to the next class you must know what we are discussing in the last class because it is then only you can understand the concept easily in the class आपको previous class में क्या पढ़े थे वो याद रहे तो मतलब वो मालूम है तो ही आपका मतलब क्लास में समझ में आता इजीली समझ में मैं आज छोड़ को गए यू आया तो आपको पूरे तो समझ में आता है बट इट्स व्हाट इट विल टेक टाइम अगर आप थोड़ा देख लेके आएंगे तो थोड़ा आसान ओके नेक्स्ट व्हाट इज स्ट्रेस okay here stress means whenever the forces are applied on the body okay suppose here you can take this shear force or you can take tensile force okay whenever you apply any kind of force on the body some opposite forces will develop inside the body which are not visible to us okay यहाँ पे जब आप फोर्स अप्लाई करते हैं बॉडी पे कहीं पे भी आप एक वॉल पे फोर्स अप्लाई कर रहे हो तो वहाँ पे भी उसके अंदर से इंटरनल अपोजिट फोर्सेस डेवलप होते which are not visible to us okay when the forces are applied on the body internal opposite forces or resistance forces develops so those internal opposite forces or those internal resistance forces we call as a stress suppose if you are applying the force like this okay internal opposite forces will develop like this internal opposite forces I am using the word here opposite are you getting or not whenever you apply force on the body some internal opposite forces are going to develop inside the body so those internal opposite forces or those internal resistance forces we call it as a stress are you getting and my board पे ऐसा force apply करूँ बोले तो in board also some opposite forces are developed okay which are inside the board which are not visible to us okay those internal opposite forces okay those internal resistance forces we call it as a stress are you getting if you can use internal opposite force or you can use the word internal resistance forces okay are you getting my point so such forces which are developed inside the body we call it as a stress okay we have discussed in detail in the last class हम बोलते हैं कुछ टायर्ड हुआ अगर तो ये बहुत स्ट्रेस मतलब टेंशन हुआ तो बोलते हैं स्ट्रेस हुआ बोलते स्ट्रेस क्यों होता हो तुम ज्यादा सोचे तो अगर ज्यादा नहीं सोचे तो आपके अंदर से वो स्ट्रेस नहीं आता आई एम गेटिंग माय पॉइंट स्ट्रेस जब आपको स्ट्रेस कब होता जब आपको प्रेशर रहा तो स्ट्रेस होता मतलब ऊपर से थोड़ा वर्कलोड ज्यादा हुआ कुछ भी ज्यादा वर्क हुआ आप टेंशन लिए तो स्ट्रेस होता टेंशन नहीं हुई तो स्ट्रेस नहीं मतलब स्ट्रेस जो वर्ड है कॉमन वर्ड है एक्चुअली वो स्ट्रेस क्या है तुम अपोजिट तुम अपोज करते रहते हो जो भी आपको लोड होता है प्रेशर होता है तुम अपोज करते रहते हो तो इसलिए आपको स्ट्रेन होता है टायर्ड होता है आर गेटिंग माय पॉइंट आर गेटिंग दिस इज व्हाट अबाउट स्ट्रेस ओके स्ट्रेसेस आर डेवलप ओनली व्हेन द फोर्स ऑफ दैट फोर्स है कोई स्ट्रेस डेवलप होता बॉडी में अगर फोर्स नहीं तो स्ट्रेस नहीं अगर मैं सिंपल एक बॉडी लिया इसके ऊपर कुछ भी अप्लाई नहीं किया फोर्सेस then there will be no stress in the body are you getting this is about the stress and again the stresses are also classified into many types but from the point of syllabus we have here you have only three kinds of stresses which are those tensile stress compressive stress and again shear stress okay tensile compression shear stress okay what do you mean by tensile stress before that tell me how do you calculate what is the symbol used for this stress sigma we use sigma the symbol to denote the stress and what is the formula to calculate the stress force divided by cross sectional area agar aap samjho if you want to calculate what is the stress developed in the body due to this force suppose if you take the force as 10 Newton you are applying न्यूटन एंड यहाँ पे कहाँ पे अप्लाई हो रहा है, कौन से सरफेस पे, ये सरफेस पे अप्लाई हो रहा है, तो इसका एरिया लेना। ओके, इफ यू टेक 2 मीटर स्क्वायर एरिया और गेटिंग फोर्स कहाँ पे अप्लाई हो रहा है, वो सरफेस का एरिया लेना कैलकुलेट करने के लिए। तो ये बॉडी के अंदर कितना स्ट्रेस डेवलप हुआ ये फोर्स की वजह से, देन you have to calculate like this. Force is how much there? 10. And what is the cross sectional area? This area you have to take. You cannot take this area. Force जहाँ पे अप्लाई होना है वो एरिया लेना चाहिए, पूरे बॉडी का एरिया नहीं। Are you getting it? So area is how much? 2. So how much you are getting? 5 Newton per meter square. About stresses we have discussed in the previous classes. Units. About units we have discussed in last previous classes. Okay. तो यहाँ पे क्या हुआ? कितना डेवलप हुआ? 5 Newton per meter square. So due to this force, stress developed in the body is 5 Newton per meter square. Are you getting? This is what about the formula and symbol for the stress. And what do you mean by tensile stress now? The stresses, I said, whenever the forces are acting on the body, stresses will develop in the body. जब भी फोर्स अप्लाई करते हैं तो बॉडी के अंदर स्ट्रेस डेवलप, स्ट्रेस बोले तो क्या, इंटरनल अपोजिट फोर्स, इतना चालू, स्ट्रेस बोले तो इंटरनल अपोजिट फोर्स। आई एम यूजिंग रिपीटेडली दिस वर्ड स्ट्रेस स्ट्रेस स्ट्रेस, स्ट्रेस बोले तो अपोजिट फोर्सेस, इतना याद रखो। ओके, whenever you apply the force on any body, stress will develop. Okay. And here the stresses which are developed due to the tensile force. This is tensile force. This is tensile force or not? What is tensile force? The forces which are acting away from the body. Okay. अभी ये force apply कर रहे हैं, tensile force apply कर रहे हैं, तो ये यहाँ पे force apply हो रहा है बोले तो body में stress develop हो रहा है. The stress which is developed inside the body due to tensile force, that is nothing but tensile stress. The stresses which are developed due to tensile forces is called as tensile stress. Are you getting? Similarly, what is the compressive stress? The stresses which are developed due to compressive force. अभी यहाँ पे मैं, so now if I take and when I apply the compressive force means the force which are acting towards the body. अब यहाँ पे फोर्स अप्लाई कर रहा हूँ बोले तो फोर्स जहाँ पे भी आप फोर्स अप्लाई करते हैं तो वहाँ पे स्ट्रेस डेवलप होता ही होता है। वो क्यों होता है? एज पर न्यूटन्स लॉ ऑफ मोशन, वी हैव डिस्कस्ड इन लास्ट क्लास। ओके, दैट इज डिफरेंट इशू। तो जब भी फोर्स अप्लाई करते हैं बॉडी में तो वहाँ पे स्ट्रेसेस डेवलप होते ही होते 100%, नो डाउट एट ऑल इन दैट। ओके, सो हियर आई एम अप्लाइंग कंप्रेसिव फोर्स। तो आप यहाँ फोर्स अप्लाई करें तो अपोजिट फोर्स बॉडी के अंदर डेवलप होता है, दैट इज नथिंग बट स्ट्रेस। The stress which is developed inside the body due to compressive force is called as compressive stress. Are you getting? Next, similarly, shear stress. What do you mean by shear stress? The stresses which are developed due to shear forces. तो यहाँ पे मैं shear force अप्लाई करता हूँ, this is shear force. Okay, अभी आप force अप्लाई कर रहा हूँ बोले तो stress डेवलप होता है, और stress कैसे डेवलप होता है? Opposite direction में होता है. Inside the body there is the stresses will develop opposite to this shear force. So the stresses which are developed due to this shear force are called as shear stress. Okay, this much we have discussed about in the previous class. Okay, the symbol for shear stress is what? For tensile and compressive stress we use sigma only. Okay. In some book for tensile stress they use sigma T, okay, and for compressive stress sigma C, okay, but shear stress the symbol is used for this. The symbol used for shear stress is tau. Okay, this everything is there in the notes. Okay, now we shall discuss about again important topic. So here here I will take a body which is fixed at one end, means यहाँ पे hold किया, fixed बोले तो यहाँ पे hold किया, okay? So this is, you take this as a body only. Whenever I use body, object, material, आप कौन सा भी एक ऑब्जेक्ट इमेजिन कर सकते हैं, ऑलरेडी ऐसा नहीं कि बोर्ड में जैसा है वैसा इमेजिन करना करके कुछ नहीं, आप कैन इमेजिन एज ए चॉक, यू कैन इमेजिन एज ए डस्टर, यू कैन इमेजिन एज एनी रॉड, ओके, कुछ भी. So here I will take a body, okay. So here I will apply some kind of force. What is the type of force here? कौन सा, compressive, tensile, shear? Tensile, because this force is moving away from the body, so it is a tensile force. Okay, you can take compressive also, no problem. So, yeah, tensile. ये direct. You have to decide based on this arrow mark. अगर वो body से दूर जा रहा है तो tensile, body के तरफ जा रहा है तो compressive. And here now I will apply the tensile force on this body. Okay. So यहाँ पे you just imagine this is as a rubber. Okay. हर एक material की same behavior करता है. Just आपको easily समझ में आएगी. Just imagine this is a rubber. Here I am holding this rubber. Okay. I am applying tensile force on this rubber. Up to particular load, there will be no deformation. अब मैं सिर्फ ऐसा थोड़ा force apply करो, कुछ भी deformation करना. When I increase that force, okay, it will start to increase its length also. Am I right? Because this force is acting away from the body, that is tensile force, means इसका length increase करता हो. Am I right or not? अब increase हो, length increase होता, cross section decrease होता. Cross section बोले तो ये. Are you getting or not? Suppose if the original length of the body is L, okay, यहाँ पे इतना length increase हो रहा है due to this force. Means here the deformation is taking place. Are you getting or not? Due to this force, the body got deformation. Okay, how the deformation has taken place? Here the change in length is taking place. Are you getting or not? So यहाँ पे change in length कितना हुआ? कितना ज़्यादा हुआ length? Delta L. Okay, you can take another example using compressive force. समझो. So again, you take the example of rubber itself. If I apply the compressive force, so what happens? Up to a particular level, it will not deform. It will not get deformed. Okay, when it goes on increase the force, so deformation will take place. How the deformation will take place? The length decreases. Are you getting or not? So here, if original length was L, okay, change in length. कितना length कम हुआ? Delta L. Okay. So here, when you calculate the ratio of change in length to the original length, that concept we call as that topic we call as a strain. Change in length by original length. So when you calculate the deformation, okay, with respect to the length, okay, the ratio of change in length to the original length we call as a strain. Are you getting? When you calculate the deformation, okay, when you consider the deformation, considering the length, okay, the ratio of change in length to the original length. So this divided by this we call it as a strain. Okay. In general, जब भी strain करके बोला था कि just remember that deformation हो रहा है. Okay, suppose 0.5 meter deformation delta L. Original length कितना है? 10 meter. Are you getting? So how do you calculate this strain? How much deformation is taking place here? Change in length is 0.5 divided by 10. Again 0.05. Am I right? 0.05 deformation is taking place. इतना change in length हुआ है, तो इतना strain develop हुआ है. Are you getting it? So here when you consider the deformation, considering the length of the body due to the forces, so the ratio of change in length to the original length is called as strain. Okay, in the exam, if they ask for defined strain, you just write that the ratio of change in length to the original length is called as strain. The ratio of change in length to the original length. Change in length कब होगा? मैंने apply the force. अगर force नहीं बोले तो डिफॉर्मेशन होता ही नहीं. अभी मैं ऐसे चाक को मैं कुछ भी फोर्सेस अप्लाई नहीं किया, इसमें डिफॉर्मेशन होने के चांसेस है? नो. So deformation takes place or strain develops only when the forces are acting. Okay, when you consider the deformation, considering the length of the body, okay, so that concept is called as a strain, and the strain is calculated by the ratio of change in length to the original length. The ratio of change in length to the original length is called as strain. Okay, and the symbol used to denote this strain is epsilon. ऐसा E करके नहीं बोलते, इसका epsilon बोलते हैं. Okay, in some books it is shown like this, and in some books it is shown like this. Okay, E capital E बोले तो ऐसा नहीं लिखना, ऐसा तो लिखना, ऐसा तो लिखना. Are you getting? Strain. Is there any doubt? Strain means the ratio of strain means deformation. Strain comes into picture only when the deformation of the body takes place. Otherwise, no. And what is the unit of the strain here? This delta L is also having the length, unit as meter. Okay. Length also, if you express in the meter, the unit of the meter length is also meter. This meter will get cancelled. Okay. So it means the strain does not have any unit. It is a unitless quantity. Are you getting? यहाँ पे delta L, यहाँ पे 0.5 मीटर है. Length कितना है? 10 मीटर है. Okay. यहाँ पे दोनों मीटर हुआ, तो मीटर कैंसिल होगा तो strain cancel हो जाता है. So there will be no unit for the strain. Okay, in competitive exam it was asked many times. The unit of strain is meter, mm, ऐसा लिखे हुए. Okay, and unit test करके लिखे हुए. Okay, so this strain has no unit. Okay, unitless. Are you getting? Is there any doubt? Strain means deformation. बॉडी में स्ट्रेन डेवलप हुआ हो तो डिफॉर्मेशन माना के समझना. स्ट्रेन कैसा स्ट्रेन बोले तो कैसा डिफॉर्मेशन? चेंज इन लेंथ वाला के समझना. आर गेटिंग आउट? ये बॉडी में ये चौक में स्ट्रेन मारे तो बोलते हैं. स्ट्रेन मार बोले तो चेंज इन लेंथ वाला के समझना. आर गेटिंग? स्ट्रेन बोले तो क्या है टेक्निकल वर्ड, ऐसा कर तो ऐसा कैलकुलेट करके क्या समझ क्या आप ज्यादा मत सोचो. स्ट्रेन बोले तो डिफॉर्मेशन, and the deformation is considered based on the change in length. Strain बोले तो change in length वाला समझो. Change in shape. Are you getting? Next we shall discuss about the type of strain. Again there are three types of strain. Okay. Tensile strain, compressive strain, and third one is shear strain. So we shall discuss one by one. Is there any doubt? So here we shall discuss about the tensile strain. Okay. So here the strain which is developed due to the tensile force. So that strain is called as a tensile strain. Are you getting? The strain means the deformation which is taking place in the body due to the tensile force. Okay. So that strain, that deformation we call as a tensile strain. The strain which is developed due to the tensile forces. So that strain we call as a tensile strain. इतना यहाँ पे देखो आप टेंसाइल फोर्स अप्लाई किए, यहाँ पे स्ट्रेन डेवलप हुआ, स्ट्रेन बोले तो चेंज इन लेंथ हो, मतलब डिफॉर्मेशन हुआ. ओके, ये स्ट्रेन को which is developed due to the tensile force, that strain we call as a tensile strain. The strain which is developed due to tensile forces is called as tensile strain. Are you getting? And this tensile strain is calculated as so when you apply the tensile force, okay, tensile force, obviously length will increase. Okay, change in length बोले तो जितना length increase हो, increase in length, that is delta L only, increase in length, or you can write it as change in length also, no problem. Change in length लिखे तो चलता, change in length बोले तो increase ही होगा. तुम्हारे ऊपर डिपेंड, change in length लिखेंगे क्या? When you apply the change in length कैसा हो रहा है पे increase होके हो रहा है. Are you getting or not? Change in length कैसा हो रहा है tensile force apply करने के बाद length increase होके change हो रहा है. तो इसलिए यहाँ पे increase in length, increase in length or increase करके लिखो can write bracket change increase change in length divided by original length. Okay, आप change in length पर original length भी लिख सकते हैं. But when you apply the tensile force, change in length is taking place by means of increase in length. Are you getting my point? So that's why I can write increase in length, or you can write change in length also, no problem. Okay, similarly, what do you mean by compressive strain? The strain which is developed due to compressive force. यहाँ पे देखो, when you apply the compressive force, okay, whatever the deformation, whatever the strain will develop, that strain is called as a compressive strain. The strain which is developed due to compressive forces, so that strain is called as a compressive strain. And here, when you apply the compressive force, so change in length is taking place by means of decreasing in length. यहाँ पे change in length कैसा हो रहा है? Length decrease होके हो रहा है compressive force apply करने के बाद. So for that, I can write the formula like this: decrease in or change in length. इसे भी change in length भी लिख सकते हैं आप, no problem. Change in length divided by original length. Okay. और इसे ऐसे भी लिख सकते हैं डायरेक्ट. In short, you can write it as delta L or DL. DL by capital L. Change in length by original length. इसे भी delta L by L. Are you getting? Now we shall discuss about the shear strain of this diagram. There the shear forces are acting. जब कैसे एक्सिस के सिंबल होते हैं वहाँ पे फिक्स है करके समझना. वहाँ पे कुछ भी मतलब कुछ भी फोर्सेस नहीं है, कुछ भी नहीं है, फिक्स रहना. ऐसा हैच करो, यहाँ हैच करो, यहाँ हैच करो. Here also have done the hatches. Shear force means what? Here I am applying the shear force like this. Okay, so up to particular force, that there is no deformation will take place. So, but when I goes on increase the force, so here the body will get deformed. So कैसा deform होता? ऐसे move होता. मतलब ये जो shape जो है यहाँ पे आता, ऐसे. Am I right? ये जो लाइन है ऐसे हो, और ये जो लाइन ये ऐसे मूव करें तो आगे भी मूव होगा, मतलब अभी क्या हुआ, ऐसा शेप हुआ। Are you getting? Due to this force, shear force, the body got deformed like this. Okay, so here you can see that it is deformed by making some angle here. The angle of पहला ये ऐसा परपेंडिकुलर था, अभी थोड़ा कुछ एंगल में हो। This angle I will take it as 5. यहाँ पे जितना एंगल होता है, यहाँ पे भी उतना से, because this line and this line are parallel to each other. यहाँ पे भी सेम एंगल बना है, कुछ एंगल पे चेंज हुआ है। अब यहाँ पे डिफॉर्मेशन कैसे हो रहा है? यहाँ पे लेंथ इंक्रीज नहीं हुआ, मतलब देखो यहाँ से यहाँ कितना लेंथ है, सिमिलरली यहाँ पे भी यहाँ से भी यहाँ उतना ही लेंथ रहता। यहाँ पे डिफॉर्मेशन कैसे हुआ? बाय मेकिंग एन एंगल। Are you getting it? So this type of strain we call it as a shear strain, and also here displacement यहाँ पे देखो, इसको डेल्टा एल करके लिखूँ, मतलब यहाँ से यहाँ change of angle में. Okay, so here if I take the original length as L, okay, if I take original length as L, and here the deformation is taking place like this. यहाँ था, यहाँ से यहाँ move off by making some angle here. Okay, so here this strain can be formed like this. Shear strain is again delta L by L, but this delta L you have to take it as transverse displacement. Transverse बोले तो along the length, transverse or along the surface. Transverse displacement by original length. First tell me what is shear strain? The strain which is developed due to the shear forces. यहाँ पे deformation क्यों हुआ? Deformation क्यों हुआ? Because of shear force. Okay, यहाँ पे strain क्यों हुआ? Because of the shear force. And the strain which is developed due to shear force is called as shear strain. Okay, and this shear strain is calculated by using this transverse displacement for original length. Again the same. यहाँ पे delta L, यहाँ पे change in length हो रहा है. Change in position, so that is delta L divided by delta L by L. That's all. And this transverse strain is denoted by phi because it is making an angle, some angle here, and that angle we consider it as a phi. So this shear strain is denoted by phi. Are you getting phi as a phi? Phi. Are you getting? The strain which is developed due to the shear force is called as shear strain. Okay, and this shear strain is calculated by this formula. Change in displacement or transverse displacement divided by original. Okay, is there any doubt up to this? Shall we conclude the class? Class के conclude करेंगे? Class और बैठ के और तो डेफिनेशन कल ये परफेक्ट है तो कल की जो डेफिनेशन आराम से समझना. What do you mean by this strain? Changing in the original ratio of changing in the original. ये आप Okay, is there any doubt? So shall we continue the next class?